Hey Shiv, how are you? Yeah, I've created a new sign prediction project.
I created one of those during my initial ML days. What I did was I used a dataset which had a list of digits and numbers, and I trained a model on it, and it was working perfectly fine. What's so different about yours then?
Yeah, well, the thing is, mine works on gestures, and if you actually refer to the Indian Sign Language, or in fact, even any other sign language, it's not just limited to signs and numbers, it's actually gestures. Have you
What do you
tried
mean?
that?
So what you're saying is there's gestures for every single word,
Yeah,
and
of
it's
course.
not limited to letters and digits.
Yeah, of course. Try saying mother.
For mother, I would just spell MOTHENR.
Well, why go through all that complexity when you just can say mother with this gesture? Why just spell
I
MOT?
can say mother with just this gesture.
Yeah, of course. This is
What you're saying is that every single word has its own gesture,
Yeah.
and not just limited to spellings.
yes.
Well, even if that's the case, I can just train any deep learning based model and that would work as well. So then what's next?
Yeah, well, here's the catch. My app doesn't require machine learning. It's purely based on some observations, some logic, and some optimizations of the code.
Care to explain?
Yeah, sure. Welcome to Gestura. So, dear panel members, we are here to solve a problem. If you look at the current sign language system, you would see many projects. Every day it's a new project on sign language, but most of them only recognize static letters and digits, etc. Furthermore, these sign languages utilize some machine learning models. These models have, as you can see, with any machine learning model, they require high computational power to run on machines. So we took the problem, and we followed some objectives. So our objective was quite simple. We tried solving the problem without any machine learning model. If you can think, it's just purely based on logic. It's just a simple script which actually detects and the gesture we are trying to do. So we have also implemented real-time input, real-time gesture recognition, and also we have implemented multi-user input. So if you want to connect, everybody can do that. Also, we have developed cross-platform compatibility. We have Android application, iOS application, as well as web app for that. We have transformed it into a full-fledged platform with user authentication, payment service because we are planning to make this free, but however we are also taking an API service. Let's say if you want to use our APIs, you can just pay a small amount and you can access that. So that is all. It is based on Spring, by the way. And furthermore, the API service is currently work in progress. Okay, Baki authentication, payments, etc. Is working. And at the last, we are trying to expand the vocabulary so that it can be expanded.
Right. So let's draw the ground reality here. If you look onto your left here, the published patents for sign language models, and then on the right for granted patents. So you can see that almost every single week a new project based on sign language is being created and patents are also being published. But if you look at the right on the granted patents, you see first of all there's only two sections here with actual sign language based projects. You see that approximately only 8% of all these projects are innovative in some sense. Most of them are just copy pasting each other's datasets and getting their patients published. So approximately 92% of them are not innovative at all, and we are hoping to change that.
So, if you can see, if you currently look at the stats, this is based on a World Health Organization survey. Almost 4.2% of the population is hard to hearing or mute, which cannot speak. But if you see, we are here in the fourth industrial revolution, where technology is transforming every aspect of life. For example, you all must have known Elon Musk recently created Neuralink, right? For the disabled persons who cannot move their hands and legs, so that they could control their equipments with just their mind. So based on similar motivation, we have created the Gestura. Our Gestura is supported by many national and international policies. These are the policies which are in tune with sustainable development goals as well as UN conventions.
Alright, so now let's jump into the methodology. First of all, I'll explain to you our tech stack. As already mentioned in the objective, our project is deployed on Android and iOS and web as well. So for front end, we are using HTML, CSS, and JavaScript. And for the smartphone ports, we are using Flutter. Now, as for the backend, our script is based on Python. So we're just creating. So we have created a fast API backend for it. It accepts WebSocket connections to handle multiple users, and then there's also an NLP-based connection specifically for Android, which I'll mention in a bit. Then there's MongoDB. Since we are not having any data set, we are storing our gestures completely in form of coordinates, and they are stored in a key value format. Currently, we are using a gestures.json file, but we are hoping to change it into MongoDB, which has a similar document style architecture. After that, Spring Boot and MySQL, as already mentioned, since we are making it a platform, we are using Spring Boot and MySQL for handling all the payments and authentication. All right, onto the architecture. I'll explain to you the architecture of our platform. First of all, the user logs in. They hop into the landing page. There's two sections: the predictor and the API generator. As for the predictor, the user can just start their webcam and start making predictions and all of that. But if you want to pay for our services, you can get into the API generator. You can then log in. It's a standard login workflow. And if you're logged in, then you can make the payment and you can get your own API key and use our project as well for your concerns. Next is the system architecture.
So, our system architecture is based on modern system principles, modern design principles. Basically, we have followed a microservice approach for each of the systems. So, let me go through. So, there's a user interface which would interact with the Gestura gateway. So, Gestura gateway has a microservice of authentication. What authentication does is it takes in form logins, OAuth based authentication such as Google authentication, GitHub authentication. Now, post authentication, a JWT token, JSON Web Token, is received to the Gestura gateway. Now, all the communication which require authentication would be done through JWT authentication tokens. For example, here predictor model, our prediction web page does not require any authentication, so it is directly connected without authentication. Our core network requires a JWT authentication, which is transferred wherever required. So we have applied a load balancer here. Load balancer is because basically the predictor is resource heavy. That's why if multiple connections are there, the load balancer automatically tries to balance the load into various services running. So a core network is here, which maintains a WebSocket connection with the backend API. Backend API is running on predictor. If you can all see, all of these are registered on the Netflix Eureka server to maintain a service registry. After that, the predictor is currently based on Fast API. Okay, Fast API because we are currently using MediaPipe. MediaPipe, yes, I would like to clarify. MediaPipe is a machine learning model, but we are just using for extracting the key points. Our gesture frame is just based on some logic and code, which we will demonstrate later. So the predictor maintains a WebSocket connection with our core framework. All of these are differentiated into different databases. This is based on document database, MongoDB, as told by Shiv. The core network maintains a standard user details such as username, password, etc. etc. It has a different database of SQL, and there is a payment service. We have utilized the Stripe gateway. Stripe gateway for payment. The payment service is completely. It also has a different SQL database. We have utilized microservice because let's say we are running our predictor model, and someday let's say we need to change our gateway. Let's say we want to use Razorpay, so we have to bring our payment service down. Now I don't think so that just for simple service we have to bring the whole system down. So this was the prime reason of why we have utilized a microservice approach. So benefits of this are it is scalable, it is robust, etc. Okay. So let's talk about the actual implementation, how we implemented this.
Alright, so for the implementation, as already mentioned, that we are not utilizing any ML model, so our approach gets a lot simpler. No model training is required, so you can just feed in the gesture and it can start recognizing it. There's no need of any training. Then it's faster. It's faster because since it is not doing any ML-based heavy calculation, so it works flawlessly, and it also makes it resource efficient. Hence, it can run on cheap backends and still manage to handle multiple connections. As for the code snippet, what we actually do is take in the key points of your hands. Since ISL has most of their gestures based on hands, so we extract 11 landmarks from it. There's 2 from each finger and then 1 from the wrist. The landmarks are extracted, then we normalize them using the bounding box approach. How does bounding box approach work? It takes in minimum x, minimum y, maximum x, and maximum y. Takes the midpoint from your entire hand and it draws the origin right here. So no matter wherever you do the sign, it will automatically take into account. Now, after all of this is done, after it has received all the landmarks and it has normalized, we initialize the frame counter at frame stage 0. Now, suppose you have given it a frame, it will go into the JSON file. It will scan all the items from the JSON file, and if your frame matches with any, it takes the frame stage into, and if it matches with any, and I'll explain this line in a bit. Fast UDW. If it matches with any, then it increases the frame stage variable by 1. It will stand for the next frame, then the next frame, then the next frame. Another thing to mention, all of the gestures that we record, we are assuming that any 2 different words can be separated with the help of only 4 frames. Suppose mother is said like this and daughter is said like this. So for mother, 2 frame for here, 2 for here. For daughter, 2 for here and 2 for here. So we are hoping that 4 frames are enough to distinguish between any 2 different words. That's why whenever our frame stage reaches 4, we detect the word and we send it. As for this line, the fast UDW. It is a very efficient library used for time sequence based input. What do you mean by time sequence? Well, whenever you are doing a gesture, it is a sequence of frames. So we have to centralize the landmarks. And in order to centralize the landmarks, we are utilizing fast UDW. It is a, you can say, improvement of DDW. DDW was originally an ON square based approach. This one is ON based approach only. Let's hop into the demo. Here we have recorded some videos for it. Here you can see I am doing 1 second. Alright, right here. I'm doing a single frame. Good, it is able to recognize that. I'm doing a gesture of return, it is able to recognize that. I'm doing daughter, it is able to recognize that. There's our web port, which is also working, and there's our Android port. In the Android port, I do good, morning, daughter, where, son. And I can also press the NLP button, which translates this entire thing into a comprehensive sentence so that people can understand it. Good morning, daughter, where, son. For this, we have used the Gemini model. For the live demo. Yeah.
So we are presenting a live demo for that. Wait, in this only. Escape. Go here. So you can see there is a webcam. So first, this is good, right? This is return. Wait. Connection है?
Skip past.
Sorry?
Skip past.
Okay. Yeah, there's the return. It was a bit delay because of frame delay.
It was not charging. Quite slow in taking the frames.
If you can see, our goal was, yes, single frame, I agree. But our return is completely this. So you can see it's a whole gesture based recognition. And so anything else? If because we can also show the Android demo we have developed as here. If you would like, this is our Android device. If you would like a demo, we could also give on Android. Basically, it maintains the same WebSockets connection. It's basically calling the API.
The main thing is the script and the fast API.
This is the script. What actually it does is it takes the start frame. If you would see start frame, mid frame, mid to frame, and when the end frame matches, it detects the gesture. Okay. So let me talk about the challenges we faced in while coming up with the project. So as you can see, a basic understanding is that if we have to recognize signs, we have to use ML model, and I agree with that. It's a common intuition, because American Sign Language, it has 99.5% accuracy rate. That's also trained on CNN LSTM. So for the Indian Sign Language, the issue is there is no data set. Okay, so we had to go. In fact, we tried this. We actually first tried the CNN model and an LSTM model, but our machines were not that computationally powerful.
Yeah, we actually went through the dictionary. We scanned for 50 words. We actually created all those videos, but it was just not running on the system.
We created over, you won't believe, over 500 videos for those gestures, but we were nowhere getting same kind of results as we are getting here. So we thought that we need a different approach. So we searched the web, went through research papers, and we came up with this solution. So we have completely avoided the CNN and LSTM models as we described here. The next challenge we faced was multiple user handling. As you can see, basically our script maintains some global variables. Now the issue was whenever new WebSocket connection is being established, those web connections were modifying the old instances global variables. So we applied a simple approach. We created a map of each WebSocket instance and assigned a list of unique global variables for each of the instance. The third issue was, you might have guessed, many of you, the camera FOV. In many computer vision projects, camera FOV, field of view, if someone doesn't know, field of view is one of the core challenges. For example, let's say this is my webcam. If I do a gesture here and here, these both are different. Why? Because if you can see here, x axis, y axis, whenever a camera records or media pipe gives, these x and y axis are taken into account while doing the frames. So we solved that through normalization. First, we approached a solution of rest based normalization. Basically, we have key points. So here is our rest. So we converted this, that this is our origin, and all of the other key points were mapped based on this.
Essentially what we did was, like, here's the wrist landmark. So we subtracted the wrist landmark from all the other landmarks, which made all of them related to the wrist. But it wasn't working as effectively as the bounding box approach, which we later started.
Oh, so, and the final issue was overlapping gestures. For example, if you can see, this is mother and this is daughter. So start frame is same. So there were issues creating. So what we did was, we tried in this video only, we only tried the start frame. We matched the start frame, and then on that basis, if mid 1, mid 2, mid 3 was mid 1, mid 2 and end frame was matching. If those were matched, then only it was predicting. So it wasn't able, because if we see that this is mother, right? This is mother. So the issue was coming that it wasn't able to earlier distinguish between mother and daughter, because it is both are starting with that. So we solved that like this. So let's talk about the future scope of this project.
Scope, first of all, we would try to make better normalization techniques to be able to track our hand advancements better. Because your hand is 3D, okay, so it has a depth, but your camera doesn't recognize any depth. It is 2D. So we will, what I essentially mean is, if you try to do the gesture of good like this, and for you it's the same, but for our camera this is different and this is different. What we are currently doing is, we are also recording on this and this, but we'll try to form a better normalization techniques which can also handle angles. Next is better vocabulary support. Since we do not require any training, so we are not trying to limit ourselves. We will try to expand through the entire ISL dictionary and make gestures for every word. Next is translation to any regional language. You might know about Bhashni API. What Bhashni API does is, it translates English and Hindi, like the two most commonly used language of our country, into any regional language. So what this will help us to do is help communicate all the different basically all the communities of India will be able to communicate with each other with the help of sign language through Bhashni API. Then there is offline mobile ports. Since we have a client and server based architecture, our mobile ports always rely on backend, but we will try to integrate Python into mobile as well. We have not really dove deep into it, but we will try to make the mobile ports completely offline so that it can also work in network constrained environments. Next is the NA to ASL converter. This is a completely different aspect. What this will do is convert all the words to their ISL counterpart videos so that people can learn and practice. That's it for our project. Thank you.
Questions, please.
Right now, can it do a statement? Right now, you're doing one words and then it's getting compiled.
Yes, sir.
Okay. Can it do a statement?
Sir, the nature of ISL is that it is already broken down into words. It does not have any long gesture for any statement. If it had, we could also. Yes.
That's correct.
Yes.
It works like with word to word.
Yes.
But I have seen the news for the disabled person. They do like this, and there's the whole statement. So
Yes.
right now, what you're doing, you're writing mother is good for daughter. Okay. You have done very slowly.
Yes.
Mother is good for daughter.
Because
okay.
I'm not proficient in sign language, I can't do it that way.
Can the system do that? You are not, but
Definitely it can, because here I'm pressing the NLP button. What I can do is we can, as soon as it detects a word, it can automatically translate it based on the original sentence and the new word, and then it can compile the entire sentence again.
Have you seen the news with those kind of? They don't do that slowly.
Yeah,
Because
they
that
do
will
it quite
take
fast.
ages for news to get reciprocated.
To handle that, since we are using Gemini API, right? It takes a lot of delay to, not a lot, it is quite fast, but for our use case, it will be a long delay. So we'll try to use some offline based NLP as well. We would deploy it right into our backend, so that would make it faster.
I would say, what I can comprehend, it's not about the NLP Gemini side. It's more on the R system side, how we can improve to gauge the gesture faster.
Yes.
Probably in the sentence mode, that is not in the good mother sister, not in that way, but it can connect those dots very quickly. Okay. That is the future implementation of
definitely.
this, because
Yeah, I understood what you said.
right, how it will help the business or the real world.
Yeah.
Like if I can do this with video call, one person is disabled, other person also, they can do it by sign language, they communicate. But I think the implementation is for documentation purposes, right? And documentation will only happen when it's at that speed. So your logic is amazing. You have figured out something amazing. Try out that it can be, make it sellable basically.
Yeah.
Right? It's sellable is only when it's getting documented at that speed. That people, I really don't need the braille language, right? It can be a counterpart to that. Everything is documented as well.
Yes.
And that would really help them in different industries where people can easily work in the disabled.
Yeah, like the our target audience is not just ISL practitioners. It's also different types of customer-based services. Like now, any service would be accessible to the mute and deaf people as well. They can just use sign and scar through all the customer services that any company is offering.
Yeah, that's why that's where.
Yeah, one thing I like most about this presentation is like the first two presentations were missing is architecture diagram. We are presenting this as a technical presentation, right? I think for every presentation, we should have the architecture diagram. So overall, we can understand your entire system, with how it is behaving, how end-to-end things are connected, how they are working inside. So that was very good addition, I guess, on your side. Apart from that, I think yeah, we have developed a very good algorithm. But
The third SQL database. Like,
can you go back to your
So the third SQL database is because our payment service is modularized. So basically, this database only maintains the records of all the payment services, all the payments we did. Yes, sir, I can combine with the above two. But the issue is, sir, if our payment service is down, and yes, actually you are right.
need to happen. Even I would say you don't need three even. Whatever you can do, it can be done in a single one. You choose any of them, whichever.
No, sir, we need to. The reason behind is that our document database is storing gestures. If I can show you the gesture.json file we are currently using. Oh, no, just a second. Yeah, wait. Sure. Yeah, The format. Yeah, if you can see our gesture.json file, what it does is for every keyframe, yeah, just like we stored this. So what it does is start, and for that start it stores these 11 key points, right? And this for mid. So basically our database, which is document DB, it is quite the read operations are very high here. So if we merge that with our user database, that would create blockage.
It will basically make the predictor system very slow. The efficient lookup of map really helps us a lot.
And one more thing, like what you have mentioned is predictor, right?
Yeah.
Many times, like what exactly is this?
So it just shows different instances. Like suppose you are using a service and sir is using a service and he is using a service.
This is a load balancer here we have applied here. Let's say you are using, and if this model is already serving is serving you, so what it will do is it will serve you, so that you both get good experience.
Why I was saying, because the core part, what other action item does this core part do?
So our core parts is very simple. It
Just auth,
yeah.
then it won't have.
For all, I don't think we need to have any data.
That's why I was saying ना कि you can have it in one only. Like auth में आप कितना redirect करा लोगे जिससे कि आपकी performance impact आ जाएगी. मतलब आपका जो main crux है कि मेरी performance low ना हो जाए, उसके लिए आप MongoDB use कर रहे हो, right? आप इसमें सिर्फ आपकी एक user authentication है, तो वो भी वहाँ जाता है.
Sir, we are using this because we are doing payment service, right? Now for that we need asset properties. Now SQL database provides us by default that. So it's basically a modular structure, I would say. Let's say we want to change something in code structure. Okay, so it is currently basically this database is exposed to this. Now there is no security here. What if it is able to somehow access this database, the user database, if both are merged? So that's it enables us to secure our systems more, because as you can see, there is no authenticator here. If there is no authenticator here, then and this is communicating with our database. Now somehow, let's say it is able to manipulate the data stored of the user. So that's a bad practice in the industry, I would say.
Then we need to write better code.
That's the ultimate solution for everything.
Or we can write the edge cases ourselves. So we relied on the database.
You have to see the cost as well. Like when you go out, it's all about cost. Okay, so if you say I'll do this better when you provide me the supercomputer, someone is going to give you a supercomputer. Yes, you have to work in the best resources available. So that's the only problem. But yeah, great stuff, guys. Great stuff.
Yeah. Thank you, sir.
My comment also. Wonderful project and again very noble cause. बहुत अच्छा इसके पीछे behind this a very good cause of doing this project, पर इस पे थोड़े बहुत और काम करके इसको I just don't know, पर ऐसा बना दो कि ये छा जाए और बहुत हेल्पफुल हो जाए. क्या चाहिए, कैसे करना है, टेक सजेशन, टेक डू, मतलब अभी ये मुझे लग रहा है इट्स अ वेरी इनिशियल स्टेज, राइट?
Yes.
तो बट इसमें बहुत सारा काम बचा है एज पर माय अंडरस्टैंडिंग. सो टेक सजेशन जिससे भी आप ले सकते हो, डू मोर वर्क ऑन इट एंड प्रूव योरसेल्फ एंड गेट इट पैटर्न एंड इस पे छा जाओ.
Okay.
You know, you will make lot of money.
And who worked on what part?
Sorry.
Between you, who worked on what part?
I worked on all of the backend stuff of the fast API, and he worked on making it a platform.
So the core algorithm we worked both. He came up with the normalization stuff which solved our FOV. Integrating with the fast API, it was his stuff, and I worked on the Spring Boot and web platforms. And
I also worked on the Android port, and he worked on.
Good job. Very
Great. Thank you.
thank you. Any questions?
Yeah, any questions?
Audience?
None. So,
Thank you.
thank you.
Thank you.